example, we are given a function y equals x to the fourth plus 2x squared minus x, and we are given a point 1, 2. We are asked to find the equation of the line, of the tangent line. Find the equation of the tangent line. Now, this is so much easier because we have differentiation rules. We know how to determine this. So y prime, or if you want, dy over dx will be, can anyone give us the answer? I need to hear everyone speak, please. Please.
4x to the third plus 4x minus 1.
Very good. So I have y minus y1 equals the slope x minus x1, and I know that this is 1 and this is 2. I'm missing this. How do I determine it?
Plug in x to the derivative.
Plug in what?
Oh, like, I guess 1.
Excellent, very good. So dy over dx, this is how we write it when x equals 1. So I have 4 plus 4 minus 1. 4 plus 4 minus 1 is 7. So then the slope is 7 at that particular point. Any questions before we continue? Any questions?
I've got a real quick question, Professor.
Anything, yes.
So the x equals 1 that you put down at the bottom, is that similar to like the limit where we have to have that for every equation?
It's a perfect question. Thank you for asking that. See, if I had denoted this by f prime of x, I wouldn't need to use this notation. I would have said f prime of 1. And that is 7. But because I'm alternating between these notations, I want you to see how we have to write it in different situations. So if I write f prime, this is much easier. But if I write dy over dx and I want to evaluate it somewhere, then I don't have anywhere to put this. You will not know what this means if I don't tell you that I'm replacing x by 1. So if I write this, what does this mean? What is it? How come the dy over dx all of a sudden is this? What for? How? That's why I need to tell you what I'm doing. In dy over dx, which is this expression, I'm replacing x by 1 so you know what happened. Is that clear?
Yes, thank you.
Thank you. And this would have been f prime of 1. So you know what, because if I write this, you're going to say, rightfully so, what? But now it's very clear. I'm plugging in 1 in this expression. Thank you for asking that. So now we have y minus 2 equals 7, x minus 1. So I have y equals 7x, and this is minus 7 and plus 2. So this is the equation of the tangent line to the graph of this function at this point. Okay, let's also look at a word problem. Okay. Like the equation of motion, so we have the motion s equals t to the fourth minus 2t to the third plus t squared and minus t. This is in meters. And this is the motion, equation of motion. So this is the motion of a particle. Okay. And t is in seconds. Okay. Find the velocity and acceleration. That's our first question. Velocity, acceleration. So what is the velocity with respect to, what is the connection between the velocity and the distance formula?
Velocity is the derivative of s.
Very good. So S prime is the velocity. So V or V of t or S prime of t are the same. So can anyone give us the derivative of this function? Oscar, would you like to give us the derivative of this function?
So it would be 4t raised to the third minus 6t raised to the second plus 2t minus 1.
Excellent, great job. Good. Can anyone give us the acceleration, which will be the second derivative of the distance or the first derivative of the velocity? Can anyone give us this?
Can I try?
Yes, please, please.
It's 12t squared minus 12t plus 2.
Very good. That was part A. Part B. Find the acceleration after 1 second.
So we're going to put t as
Right.
equal to 1.
The acceleration of 1. Good. So 12 minus 12 will be 0 plus 2. 2. Measurement unit. Please do not ever forget the measurement unit. What is the measurement unit?
For velocity, I think it's meter.
So distance
meter per second.
in meters.
Mhm.
Velocity in
Meters per second.
thank you, is always a ratio, right? Because the velocity is the rate of change of distance with respect to time. The velocity is a rate of change. I'm not going to say to you that I'm driving at 40 miles, but I'm going to say I'm driving at 40 miles per hour. It's a rate of change of distance with respect to time. Very good. Now careful. Acceleration is the rate of change of velocity with respect to time.
Meters per second squared.
Thank you very much. Absolutely. Meters per second squared. Thank you very much. Was it Carson, right? So meters per second squared. That was part B. Okay. So moving on to, I'm picking problems because it's easier for me. I'm just showing you where I'm picking problems. This is an old edition of the book because it's easier for me. But if you feel like picking any problems from WebAssign ebook, please tell me and I will copy that problem. So now I would like to pick a problem from here, maybe something with differentiability. So that's where I'm looking. So I'm looking somewhere between 58 and 68 now. So I have it here because it's so heavy on my side. Okay, so let's look at yeah, 68. I just said that. Let's look at 68. 68 in my book. I shouldn't even mention the number because I don't know. In the new book is the same. So at what numbers of is this function differentiable? Okay, so we're given a function g of x, and this is 2x for x less than or equal to 0, and it's 2x minus x squared for x between 0 and 2, and 2 minus x for x greater than or equal to 2. Okay, so at what numbers is the following function differentiable? And then they want us to find the g prime and graph both. This is an important type of problem. So let's work on this slowly. Okay. Because this shows a lot of depth understanding of what's happening here. Okay. So first of all, we know differentiation formula, so now this will be easy to identify or determine the derivative. Can anyone give us the derivative of 2x?
2.
Okay, I wanted to also hear Josh and Trey and Ian and Javon, everyone else, please. Notice that I will not write the equal symbol. I know for sure, it's 5 minutes. So I know for sure that this 2x is differentiable and the derivative is 2. But I'm not sure whether this function exists at 0 yet. That's why I'm not going to put the equal symbol. Can anyone give us the derivative of the middle piece?
The 2 minus 2x.
2 minus 2x, gorgeous. 0, perfect, good. Can anyone give us the derivative of the last part? And notice that I cannot write the equal symbol just yet.
It's -1.
-1, perfect. Okay, at this point, we're asked, is this function differentiable everywhere? Where is not differentiable? I know it's differentiable to the left of 0, for sure. This is a differentiable function. It's a polynomial function. I know that this is differentiable everywhere, but I'm interested in 0 too. Yes, for sure. I know that this is differentiable everywhere to the right of 2. What I don't know for sure is what happens at x equals 0 and what happens at x equals 2. I don't know if the original function is differentiable at 0 and 2. I know it's differentiable for sure everywhere else. If the function is continuous, if this function is continuous, it doesn't mean that it's differentiable. It can still have a corner or a cusp or a vertical tangent. Not in this case, but it can still be not differentiable at those points. So, is this function continuous at 0? Yeah, the limit from the left of 0 is 0. The limit from the right of 0 is 0. Is it is it continuous at 2? Yes. So from the left of 2 is 4 minus 4 is 0. From the right of 2 is also 0. So I know it's continuous everywhere. But I don't know if it has a corner or a cusp. In this case, they're all, anyway, so they're polynomial functions. I don't know if it has a corner or a cusp at 0 or 2. So what do I need to do at this point? After I check, and I did check, I didn't write it, but let me write it here for you to understand that we have to check continuity first at 0 and 2. This is a must. First, we have to check continuity. I checked, but I didn't write it. So maybe I should just show first continuity. Continuity. I don't want to cut corners. So continuity at 0 and continuity at 2. So I have limit as x approaches 0 from the left. And 0 from the left is from 2x. It does equal limit as x approaches 0 from the right, from 2x minus x squared. And it does equal f of 0. All these are equal. This is 0, this is 0, this is 0. Yes. Now continuity at 2. Limit as x approaches 2 from the left, and from the left was 2x minus x squared. Yes, it does equal limit as x approaches 2 from the right of 2 minus x, and it does equal f of 2. This happens to be 0, this happens to be 0, this happens to be 0. I'll say check. Now I created the derivative, and now I have to check differentiability at 0 and 2. So now differentiability. Of g of x at x equals 0 and x equals 2. Okay. So I will determine the limit from the left of 0 for the derivative and the limit to the right of 0 for the derivative. I will determine the limit from the left of 2 for this and the right of 2 for this. Why? Every time the derivative is continuous, the original function is differentiable. So that's what I'm looking at. So is G prime, so limit of 2 as x approaches 0 from the left, does it equal limit of 2 minus 2x? Got it. 2 minus 2x as x approaches 0 from the right? Yes. Because this side is 2 and this side is 2. So then differentiable at x equals 0. For the other one, so limit as x approaches 2 from the left of 2 minus 2x, does it equal limit of -1 as x approaches 2 from the right? So 2 from the left of this, 2 minus 4, this is -2, this is -1, not differentiable at x equals 2. So after I look at the derivative, I create a derivative,